My name is Ryan Krattiger. I'm at Kitware. I work on the SPAC project doing CI and build caches. And so in that we do quite a bit of signing. We'll look at that in this presentation here. And so I was a CFD researcher, and then I started doing build systems, and I just never got away. And so I'd make this joke every presentation, so look forward to the next one. So signing, why do we care? What are some workflows, basic workflows, and then I have a couple examples here that we'll go through. So the main two reasons most people care are artifact integrity and supply chain security. But also cryptography is cool, and so we like to do that. Here you can see a really simple diagram. You have a developer who is uploading something. You have a man in the middle, and they change what the user receives with something malicious. Signing lets us add some additional information around the artifacts we're sending to users so they can verify if those things are from a trusted source. So here's a simple workflow. I've tried to strip out as much as I could here. So the key management, we'll talk more about this in the next slides, but it's access controls, key lifetime, and handling key exfiltration. And this is very important because the key is how we, verify identity across these transactions. As far as the actual signing, you have a private key in most cases, the asymmetric key. You sign your artifact in some signing location, and you send that out to the internet. The important thing here now is to communicate to users what you use to sign, and so you publish your public key. The user will download that public key, verify that the identity of that public key is who they expect, trust that key, and verify the signed artifact, and everybody is happy. So key management is hard. So uploading your public key, there are lots of ways to do this. I'm not going to go through all of these. There are different formats, different ways to share, different ways to communicate changes to keys. In the back alley, you have a USB drive, you swap with your friend, sort of thing. So screenshot here for SPAC, we have public key ring that we upload to a website. You can use this to verify the identity of SPAC keys. And then for CMake, we use another type of key ring that we publish. So private keys, you don't publish these to the internet, please. Often these are stored in key management services, in vaults, at national labs, stored on some very special computers that can never die. If they do, then you can no longer sign things. And recently we're seeing limited lifetime certs coming around. So you don't store the key, you get the key on the fly. If you do store your key, what happens when it's exfiltrated and somebody else gets it? You need to communicate this to the people using your signing keys. And this is very hard because most people will trust your key once and they will never look again. And so communicating these things to folks is really important. And with GPG, you can do things with like subkeys so you don't have to destroy your primary key and all these sorts of things. And SigStore is, we'll show an example later. But it doesn't require revocation because the key only lives for about 5 minutes, and then it's expired. You can no longer sign with it. So what else can we do to make it better? So if we can't really communicate Revocation, easily, one of the things we can do to sort of reduce the blast radius of key exfiltration is to rotate our keys regularly. You set expirations on your key. After a certain amount of time, it can no longer be used to sign. Now users have to go and get a new key. They're forced to. Like, this thing is no longer verifiable. I need to go and check for the update. This is still hard, though, right? You need to communicate these things to a common place. You need to get into all these key rings. If you have complex infrastructure, this is a lot of different places that need to be updated together. If you're not using a subkey for GPG, you're changing your root key, and that can be annoying because now people have to re-verify the identity on that primary key. So there are challenges in rotation. So let's look at an example. So CMake has a relatively simple workflow, and we benefit from sort of being behind a firewall the whole time. So we create artifacts in GitLab on our services. We put those on a signing server, and on that server we have a key that gets rotated every so often, and that is used to sign. We use a public SKS server, key server to upload our public keys, and so to get keys, you just go and locate keys. It'll go and update keys for you, that sort of thing. And then the user is able to follow that, trust the public key, and verify their artifacts. So this is about as simple as you can get, I think, in a real sort of workflow. So let's make this more complicated. What if we have multiple sites? What if we have hundreds of thousands of things we need to sign every week? This becomes a little bit more of a problem. So in SPAC, we have inside AWS a key management server that hosts the private keys. We have sealed secrets that are decrypted with those. And these will let us mount secrets onto our cluster nodes inside AWS, as well as a very special notary node that gets additional permissions that no other node in the cluster can have. In addition, we also have on-prem resources for SPAC CI, and so right now these are just at UO, but if we add more, this will also be a problem. And so those on-prem runners have the keys themselves that need to be managed, and then everybody needs to communicate these keys up to the build cache there. And so there's a lot of stuff going on in here. So let's take a step back. So what do we sign in SPAC? We don't actually sign the binary data itself. It's too big, and that would be frustrating. So we sign these manifests. In these manifests, we record the digest, the size, and we have some type information about all this stuff. Currently, we're using a clear text signature, and so this is sort of wrapped around the data here. We're moving towards detached signing coming soon. There's an issue right now in a branch on my other laptop for that. All right, so in a single key world, what would it look like for SPAC signing? We would have our runner install, build software, and now we have to send it across the open network, right? Because we're not just inside of this firewall space, we are also sort of out in the world. So we're going across networks, and maybe somebody is in the middle and they do something bad to our manifest. That comes to our notary node, gets signed, everything's fine, right? Right? No. All right, so we need something else. We need a way to go from our runners up to the cloud and then come back to the notary and be signed. And so we have this thing called an intermediate signing key. These are located on each site. They're specific to the sites. And they have their own sort of trust. We share these between the runner nodes and the notary. And then we have a second key. This is lovingly called the Guys with Guns key. It is, the primary key is stored at Lawrence Livermore somewhere. And we expose subkeys for signing, and then we can revoke and rotate the subkeys as needed. And so in this workflow, it's a little bit more complicated. So we have the builder signs with its key, and now we have something we can verify up in the cloud. We pull that down. We get our clandestine exchanged key and verify the artifact that came down. We re-sign that with the reputational key and upload the reputational key signed manifest. So that's great. So now when you go to install software, we only need one key for verification. So this is convenient for users because you need to verify the identity of the key you trust from the build cache. And if you have to do that with lots of keys, it's kind of hard. But if you have to do that with one key, it is much easier. But again, you need to verify the identity of the key you get from the build cache. I just want to say that again. I think more people need to do this. I don't know if everybody knows that we have this public key file you can check to make sure the identities match. Please do that. It's a very, very important step to make the signing meaningful. But here, yes, you download the keys from the cache, you verify your identity, and SPAC will verify that the manifests are correct, and we will install the software. Okay, so as promised, here's from the SigStore webpage, their workflow. This is a keyless signing workflow. So this is the temporary signing certificates that get issued from Folk.io. On the signing node, you have a OIDC token. You request certificates from the signing server, for the identity provider. It sends you a temporary cert. You use that to sign. That signature gets uploaded to the Recore transparency log and stored in a non-fungible database chain, also known as blockchain to some. And then on the user side, instead of going to a public key store, you query the transparency log, pull down the public key, the artifact checksum, and verify the artifact that you're downloading using the Cosign tool from SigStore. So this is convenient because now we are getting around the problems of having to communicate revocation and key rotation. This is just part of the workflow. It's less convenient because now we're using identity providers and these sorts of things. And so verifying exact identity or organizational identity is a little bit harder in this case. They focus more on email as the identity indicator here. So that is what I have for signing workflows. I'm trying to avoid getting too down into the weeds. So any questions? The question, I don't know who's moving the microphone for. Yeah.
As somebody who builds CI pipelines that need to consume things from build caches, it seems to me it would be convenient if there was a way that I could ask SPAC, given this fingerprint, tell me if the key in the build cache matches this fingerprint, so that I don't have to do it with my eyes.
Yes, that is coming. I don't have a pull request for it yet, so I'm not going to advertise it here. But
I'll open an issue.
perfect.
I have one for you. The SIG store method that you were talking about at the end there, you said it's based on OpenID Connect. Basically, comes back to like your email address. What's the disaster recovery plan there if somebody gets into my email? You said there's no like revocation step or anything. So is there anything you can do in that case?
Yeah, I mean, if your identity token is compromised, then you just need to find out when, and then everything in between needs to be expunged from the log.
Any more questions?
So I can understand what you're trying to do with like not signing the binary and signing the manifest with the size and type information, but like how can you prevent like a similar sized file that's been modified? Like, can you just go into a little bit more detail about that?
So the size is measured in bytes, and then we use a SHA-256 sum for the digest.
Oh, I see.
And so if you can
So you're not
duplicate the
signing the
size,
manifest,
and
so it's of the individuals. Okay, got it.
Yeah,
okay,
yeah,
now understand. Thank you.
we're relying on that stuff being
Okay.
good,
Right. Okay.
which I think we're okay doing that.
Any more questions?
One more over here.
So hi, Patrick Garton from Fermilab. I was there at the inception of build caches. It's something that came out of high energy physics where we actually had no concept of signing anything. We were just downloading zip files or whatever. And so it's great to see that this has come so far. We do have a trust mechanism for our distribution mechanism by default, which is CVMFS. And but yeah, it's great to see that you have moved this so far along.
Yeah, it's evolved a lot.
And yeah, I mean, came up with this very simple algorithm that this physicist came up with at the beginning, and it's come quite a ways. Thanks.
All right. Thank you very much.